Hello everybody, this is Mrs. Snook with section 8.2 and our topic is special right triangles. And there are two kinds of special right triangles. The first one looks like this. It's an isosceles triangle, so both legs are the same, which means that both of those angles are 45 degrees. And I call it a right isosceles. Or you can also see it as 45, 45, 90, referring to the degrees. Now I can do the Pythagorean's theorem with an isosceles right triangle. So if each leg equals 1, I can then calculate your hypotenuse. Just c squared equals 1 squared plus 1 squared. C squared equals 2. And then square root both sides, c equals square root of 2. Or, in a moment, I'm going to show you a shortcut that will let you quickly solve any 45, 45, 90 triangle, oftentimes just by inspection without showing any work. The second kind is a 30, 60, 90 triangle. And we discovered the pattern by looking at an equilateral triangle. So if I have an equilateral triangle, that angle is 60, and then I'm going to drop down a perpendicular bisector. So here's a right angle. Because this has been bisected, in here I have 30 degrees. So this triangle that I'm highlighting, that's a 30, 60, 90 triangle. Now check this out. If each length of my original triangle was 2, then the length of this piece is going to be 1. So I have one leg and I have the hypotenuse. I can solve for that other side using Pythagorean's theorem. I would say 2 squared equals x squared plus 1 squared. So then x squared equals 3, x equals square root of 3. So I can do Pythagorean's theorem, or I can use the shortcut, and I'll show you that in just a moment. Now this kind of triangle, the one I've highlighted, is the second kind of special right triangle, and that's a 30, 60, 90 degree triangle. Again, referring to the angles. So let's go ahead and do some problems. First up is our 45, 45, 90 triangle. I'm going to call each leg in that triangle S. I'm going to give that the variable s. And then your hypotenuse is just going to be s times the square root of 2. Just like when I used Pythagorean's theorem to solve, I had 1 on each side, and then my hypotenuse ended up being root 2. So 1 times root 2 gives you the hypotenuse. And that's going to work no matter what side length I give you. If I give you side lengths of 3, just take 3 times root 2 and that will give you the hypotenuse. So let's solve some problems just using our shortcut. We're not going to bother with Pythagorean's theorem. On our first one, we're told one of the legs is 8. Now because of 45, 45, 90 is also isosceles, x equals 8. And then to find y, the hypotenuse, I use my pattern, I take the sine, and I multiply by root 2, and I'm done. Number 2 is the same thing. We're told that 25 is one of the sides. So the other side, which is y, is going to be congruent, so that's 25. The hypotenuse, x, is 25 times root 2. Done. Now number 3, we are going to have to do a little bit of work here. And that's because we're given the hypotenuse 19, and we're asked to solve for x and y. Well, I know they're congruent, so x and y will be the same. So if I solve for x, I'll have y right away. And then here's what I'm going to do. Since 19 is the hypotenuse, and I know the hypotenuse is the side times root 2, I'm just going to divide that 19 by root 2. So I get 19 over root 2. Now don't leave it like that. You're going to have to rationalize. So multiply by root 2 over root 2. And I'm going to get s equals 19 root 2 over 2. So put in for x, 19 root 2 over 2. X and y are congruent, so y is 19 root 2 over 2. Had to do a little bit of work there. Not too bad. Now we're going to do 30, 60, 90 triangles. Short leg, I'm going to call that S for short. And the short leg is going to be always opposite the 30-degree angle. So if you're looking at a diagram and you're not sure which one is the short leg, just find that 30-degree and go opposite. There's your short leg. Your longer leg is going to be the short leg times root 3. And it is opposite the 60. So if you find that 60-degree, opposite that is going to be your long leg. And then your hypotenuse is just 2 times the short leg. So because everything is based on short leg, when you do these problems, find the short leg first. And then all you have to do is apply the patterns to get the rest of the problem. So on number 4, I'm given the short leg is 5. X is long leg, so I'm going to do 5 times root 3. Y is the hypotenuse, so 5 times 2 is 10. Done. There's no work to show. Now let's take a look at number 5. Again, I've been given the short leg is 14. This time, X is the hypotenuse, so I'm going to double 14. So I get 28. Y is the long leg, so 14 times root 3. That's done. Now look at number 6. They've given us the hypotenuse, and we're looking for both the long leg and the short leg. So do as I said earlier, find the short leg first. My short leg is going to be 32 times the long leg. Sorry. So we have 32 as our hypotenuse. That's going to be 2 times the short leg. So then short leg equals 16. So X is 16. Now I know the short leg, just apply the pattern, multiply that by root 3 to get the long leg, so 16 root 3. And 46, same thing. We're given the hypotenuse. This time Y is the short leg. So divide that 46 by 2, you get 23. X is the long leg, so 23 times root 3, and that's done. Okay, so now we have just one kind left, and that's where you're given the long leg. So 20 here is the long leg. Now I know 20 is going to be my short leg, which is Y, times root 3. That's my pattern. So I'm going to divide by root 3. So I'm going to get Y equals 20 over root 3. Please rationalize. I don't want you leaving square roots in the denominator. So Y is going to be 20 root 3 over 3. So I'm going to fill in my answer, 20 root 3 over 3. Y is the short leg. I'm going to double that to get the hypotenuse. So that 20, that doubles to 40. So I get 40 root 3 over 3. That's done. Last one, number 9. The long leg is now 9 root 3. Believe it or not, this is actually much simpler than it looks. I know my long leg 9 root 3 is going to equal X times root 3. Just divide both sides by root 3. X equals 9. Easy peasy. Hypotenuse, 9 times 2, 18. And we're done. Easy peasy. So I do have a nice easy way to help you remember the rule for the 30, 60, 90. And that is, think back to the Jackson 5. They used to sing a song that said, easy as 1, 2, 3, simple as do, re, mi, a, b, c, 1, 2, 3. I'm just going to modify the Jackson 5 song a little bit. It's going to be 1, 2, root 3. So easy as 1, 2, root 3. Simple as do, re, mi, a, b, c, 1, 2, root 3. And yes, I'm going to torment you with Jackson 5 and 1, 2, root 3, because it will definitely help you as you do these problems. So that's it for today. Thank you for watching and have a great day.